The point P with coordinates 4, 6 lies on the curve y equals the square root of x plus 4. If Q is the point x, the square root of x plus 4, we want to find the slope of the secant line PQ for the following values of x. Here we have x equals 4.1, then x equals 4.01. Notice how these two x values are greater than 4, but they're approaching the x value of 4. And then we have x equals 3.9, and then x equals 3.99. Notice how these two x values are also approaching 4, but from values that are less than 4. We know we can find the slope of a line if we have 2 points on the line, which we have when we find the slope of a secant line. In general, the slope is equal to the change in the output divided by the change in the input, or using function notation, if these are the 2 points, we'd have f of x sub 2 minus f of x sub 1 divided by the quantity x sub 2 minus x sub 1. Before we find the slopes of these secant lines, though, let's look at this graphically. Again, our ultimate goal is to find the slope of the tangent line at the point 4, 6. And we're going to predict the slope of this tangent line by using slopes of secant lines. So for example, if we decided to find the slope of the secant line through the point 4, 6 and a point to the right of 4, 6 where the point is still on the function f of x equals the square root of x plus 4, it might be this point here. And notice how the slope of this black secant line will have a slope that's approximately the same as the slope of the tangent line. As these 2 points get closer and closer together, the slope of the secant line will approach the slope of the tangent line. And of course, we can also select a point to the left of 4, 6 on the function, let's say this point here, find the slope of the secant line, and again, as the 2 points approach each other, the slope of the secant line is going to approach the slope of the tangent line. So going back to our example, because we're given y equals the square root of x plus 4, we know f of x equals the square root of x plus 4. And because we're given the point 4, 6, of course we know that f of 4 equals 6. Let's begin by determining the 2 points we'll use to find the slope of the secant lines. So we know for each secant line, we'll be using the point 4, 6, and we'll use the given x value to find the coordinates of the second point. So when x equals 4.1, the second point is going to be 4.1, f of 4.1. When x equals 4.01, the second point is 4.01, f of 4.01. When x equals 3.9, the second point is 3.9, f of 3.9. And finally, when x equals 3.99, the second point is 3.99, f of 3.99. So while we could find each of these function values by performing substitution into the given function, we'll go ahead and use the calculator to find these function values. So now we'll set up the slope for each of these secant lines using our slope formula here. And again, to save some time, I've already done this. On the right here, for our first secant line, the slope is going to be equal to f of 4.1 minus f of 4 divided by 4.1 minus 4. So notice how instead of writing 6 here, I wrote f of 4 just for consistency. Here's the change in the outputs. Here's the change in the inputs. When x equals 4.01, we would have f of 4.01 minus f of 4 divided by 4.01 minus 4. And similarly, for x equals 3.9, we have the change in the inputs divided by the change in the outputs. And finally, for x equals 3.99, we have the same, the change in the outputs divided by the change in the inputs. And again, we'll use the calculator to find these function values. And again, we already know f of 4 equals 6 because we're given the point 4, 6, but we'll go ahead and keep it consistent and use this function notation. So for the first step, we'll go to the calculator and enter the function. So we'll press y equals. We'll enter the square root of x plus 4 for y1. So we'll press secant x squared for the square root, x, right arrow, plus 4. And now we're going to go back to the home screen, so we'll press second mode for quit, and now we can find our slopes. Instead of using the function name f, we'll use the function name y1 since we put our function in y1. So for our first slope, we'll have open parenthesis, vars, right arrow, enter, enter, brings up y1. we want y1 of 4.1, so in parentheses we have 4.1, close parenthesis, minus, again we know f of 4 is 6, but I'm going to enter vars, right arrow, enter, enter, and I'll enter y1 of 4. So here's our numerator of the slope, and then we have divided by, in parentheses, 4.1 minus 4. Close parenthesis and enter. We'll round to 4 decimal places, so we'll say the slope is approximately 0.2485. And now we'll find the next slope, and we'll go through this process again. So open parenthesis, and now we'll enter y1 of 4.01. So vars, right arrow, enter, enter. In parentheses, we have 4.01, close parenthesis, minus y1 of 4. So vars, right arrow, enter, enter. In parentheses, 4. Another close parenthesis for the numerator, and we'll divide this quantity by, in parentheses, 4.01 minus 4. And enter. To 4 decimal places, we'd have approximately 0.2498. Now we could find these function values by performing substitution into the function and then find the slope, but I think by using the calculator, it will save us some time. For our next slope, we're going to have, in parentheses, y1 of 3.9, vars, right arrow, enter, enter, in parentheses, 3.9, and then minus y1 of 4, another close parenthesis for the numerator, and then divided by, in parentheses, 3.9 minus 4, close parenthesis, enter. To 4 decimal places, we have approximately 0.2516. We have one more slope for a secant line. So in parentheses, we have y1 of 3.99, close parenthesis, minus y1 of 4. Again, we could just enter 6, it'd probably be faster, but just to be consistent, we'll enter y1 of 4. So vars, right arrow, enter, enter, in parentheses 4, another close parenthesis for the numerator, and then divided by our denominator in parentheses, which is 3.99 minus 4. So to 4 decimal places, we have approximately 0.2502. And now for the last question, we're asked to guess the slope of the tangent line to the curve at the point 4, 6. Notice as we approach the x value of 4 from values that are greater than 4, looks like we're approaching 0.25 or 1/4, and the same is true when we approach x equals 4 from values that are less than 4. Looking at these two slopes, again, notice how it does look like it's approaching 0.25 or 1/4. So we'll make the prediction that the slope of the tangent line at the point 4, 6 is 1/4. Or if we want 0.25. Now if we go back and look at our graph just for a moment, here is our tangent line at the point 4, 6. And notice how if we were to select 2 points on this tangent line, let's say this point and this point here, we can verify the slope is 1/4. Notice to move from this point on the left to the point on the right, we would have to go up 1 unit and right 4 units, verifying that the vertical change is +1, the horizontal change is +4, which does give us a slope of 1/4. I hope you found this helpful.